Chemosensation, the ability to detect chemicals, is incredibly important for snakes in spatially mapping out their environment, almost as much as vision and touch is for human beings. Snakes, of course, don't always have the greatest eyes, and they definitely don't have arms, so instead they've taken to licking everything. They have a forked tongue with which they can detect the presence and absence of chemical cues in their nearby environment. Each flick of this tongue allows them to create a spatial picture of chemical trails that they can follow. Northern pit vipers, such as rattlesnakes, abuse this process even further, using the chemical cues from their own venom that they inject into prey to find the prey later after that venom has done all of the dirty work for them. The act of envenomation is incredibly crucial in facilitating chemical trail tracking, except with the possibility of one small group of vipers known as Agkistrodon, who we think might be able to do this process without requiring envenomation at all. To investigate this, we recorded Agkistrodon contortrix, the eastern copperhead, predating upon cicada nymphs during the summer of 2020. To do this, we looked at average tongue flick rates across multiple behavioral categories while these guys did their thing in the summer, and were able to find statistically significant differences between these behaviors. We were also able to find within our climbing and ground movement categories that the average tongue flick rates per minute were incredibly similar to what has been previously documented in studies on envenomated searching in other pit viper species that are related to them. This statistical evidence, in combination with the fact that we were also able to record them frequently eating cicadas at the end of these movement transects, gives strong support for the idea that they were able to track down these cicadas using chemosensory abilities without having to envenomate them beforehand. This is really great for landowners as well as recreational campers to know, because if they encounter a feeding aggregation of copperheads in the wild, they'll know that as soon as the cicadas are gone for the night, so are the copperheads. The other cool thing about this is that it's never been documented before within a laboratory or a wild setting for this species. So next time you're out in the summer at dusk and see cicadas coming out of the ground, pull up a chair and enjoy the show that is a copperhead trying to shimmy up a 15-foot tree. All right, that is it. That is the one.